So today we are going to do the equation of reflected light and incident light in vector form. So what does it mean is mirror, given the mirror, if a light ray is incident, then it will have the normal, something like this. This normal can be any direction. It could be x, y, z axis. It could be any random axis. So let's say the direction in which the normal is pointing is having the unit vector n cap. N cap is the unit vector in the direction of normal. So definitely the incident light ray will also have the direction, and we can call this as EI cap, the direction of incident ray. So what we are looking for, that what will be the direction of the reflected ray EI. So these, because the angles are equal, so there must be some relation to these quantities. So we have to just relate these three quantities. Okay. So in a way, you can say find question is like find the relation between EI, N cap, and EI. So basically, I want to express ER in terms of the EI and N. So if you look carefully, ER as a vector, because it's a unit vector, so we can write as I cap cos theta sin theta like this. So we can write as sin theta I cap, correct? Plus cos theta j cap. That's the value of ER. You can see clearly.
Yes, sir.
Okay. But how to get this answer? Like, is this the only way, or do we have some better way of getting? Because now we
So,
have got sin theta using the cross product and cos using the dot product. That will be really lengthy, and we do not want the lengthy way. Cos theta you can get from the. So if you look carefully, the EI dot n cap is basically 1 into cos of and the angle between them is pi minus theta, right? If you extend the EI direction, you can get the angle, right? So EI direction is downward, N is upward, and the angle between them is how much?
pi minus theta.
Yeah, it's pi minus theta. So in fact, the EI dot N turns out to be minus cos theta. But I cannot take a I cap and J cap again because IJ is not allowed to be taken here. That's why this method we have to leave, because we don't have I and J. We have some general axis N cap, EI, ER. Okay. So this is basically ER we can write as the sum of projection along the N cap and the sum of projection perpendicular to N cap. Okay. This is how we write. So how to write a vector? There are many ways. Of course, if you know the vector, if you know the simple vector chapter, if this is the A vector and this is the B vector, so this is called projection of B perpendicular to A. And how to get this? If you remember, this was basically B minus the projection along, which is B dot A cap. This is how we write. If you
Yes,
remember,
sir.
because this is like B dot A cap. So the perpendicular will be how much? Just subtract use the triangle. So B minus B dot A cap will give you the perpendicular. projection. So that is why, like ER, we can also write in the same way. The ER will have a component along the n cap, which will be ER dot n. Sorry, but I don't want to write now. Yeah, that's fine. So we can write as so. Okay, that, that is not required. Leave it. I was trying to find a new method, but this is not there. So I'll go to the easier method. Okay, anyway. Okay, sure. So let's do this diagram. You'll get the answer easily.
Then
Alpha.
what is this topics next?
Topic name is writing the law of reflection in vector form. Law of reflection in vector form. Like if you know the unit vector of incident ray, if you know the unit vector of the normal to the mirror, then the unit vector in the direction of reflected ray we can find in vector form. And it's pretty easy. You just need to extend this line. Which line? The X and the incident ray, and draw something like this, and draw something like this. This is a simple construction. I'll come to that how it is done. So this is n cap. If I call this as the incident ray, so the length of this ray will be 1, correct? And if I extend this in the other direction, it must be also 1. I mean, let's say extend by 1 unit in the other direction. Because this is theta, this is also theta. This is also theta. This is also theta. And every unit vector will have length 1. So it will form the isosceles triangle. Okay. And because everything is 1, so you can name it, let's say O is the point of incidence. This is the A, B, C, D. So this is the ER vector, right? So how you are going to write the ER vector? The ER vector will be the resultant of OB vector plus BD vector, correct? Triangle law. Simple enough. Do you understand this diagram?
Sir, how is OB equal to 1?
It's a unit vector, na? So what is the length of unit vector?
1.
1. So AO is the incident ray. So I'm taking a unit vector to represent it. So EI is the 1 unit length of incident ray. ER is the 1 unit length of reflected ray. Is this clear?
Yes.
So from triangle we can write this as ER equals to OB plus BD. You can see clearly. In the triangle, you can see OB plus BD equals to OD.
Yes.
Are you guys realizing this part? The triangle.
Yes, sir.
So OB is how much? So if you look carefully, the OB is the translated version of AO. Like if you move the AO vector, So we can write the ER equals to, yeah. So the OB vector is basically equals to the AO vector in lengthwise also, direction wise also. So we can write this as directly EI. Do you realize this?
Yes.
Now BD vector is interesting because BD vector is like a sum of BD we can write as twice CD vector. It's the same thing. I can write BC also. And why I'm saying CD, because CD we can calculate as a length in terms of EI. And if you look carefully, what is CD? Basically, it is up to this length in this triangle. It's a 1 cos theta, right? So the length of CD is how much? Can you see the length of CD? Length of CD is 1 cos theta. Do you realize length of CD? And direction of CD is what? Parallel to n cap. It is clear.
Yes, sir.
Length of CD you can see now it's 1 cos theta. Simple. Okay. This is theta. This is theta. This is 1. This is how much? 1 cos theta. So 1 cos theta is the length actually. Do you realize this? Yes or no?
Yes, sir.
CD is cos theta. That's it. And we have seen the cos theta formula already on the left side. You can see it's EI dot n cap. You can write as minus EI dot n cap whole n cap. This is the vector relation. So today I wanted to derive it differently, but I have to go by the conventional method. Is this clear? The vector equation.
Yes.
So once you know the incident ray direction, once you know the normal direction, you can find the direction of a reflected ray using this formula directly. So for example, let's solve one problem. If I draw some random mirror in 3D space, and if the incident ray is coming, let's say this ray is coming in the direction parallel to a vector. So the vector A and the incident ray are parallel. Okay, I will just write in words. Okay, and the normal is this. Okay, this is the normal. The n cap is written as, let's say, 2 I cap minus j cap plus k cap upon how much? We need to write 4, 5, 6 roots. So this is some random n cap, and it is given that I don't know the text. It is given that the incident ray moves parallel to a vector given by I cap plus 2j cap minus 3k cap. Then find the unit vector in the direction of reflected ray, right? All right. I hope the question is clear, not very difficult.
Yes.
So it is given that the incident ray moves parallel to a vector given by this random formula ik plus 2jk plus minus 3k, then find the unit vector in the direction of. So what will be the equation or the unit vector in this direction of reflected? Yeah, questions clear? Now if you try to solve by the common sense, I mean basic logic, it's almost very difficult. I don't think we will be able to solve because it's a 3D problem. In 2D we can draw the geometry and get the answer, right? The problem is 3D is we cannot draw the geometry and we don't know what is how it is x, y, z and all. So the only way we can solve this question is the vector form. Understand? So the formula says that it is ei minus, take the dot product of ei and n cap and multiply with n cap. So the ei is parallel to the vector which is I cap plus 2j cap minus 3k cap upon, we have to add the magnitude to make it in vector. This is a vector, not.
14.
See how much is that?
Root 14.
Very good. And if you take the dot between ei and n cap, so it is like 2 minus 2 minus 3, right? By root 14 into 6. Just check. Am I right?
Sir, it's 3 by
It's minus 3, no? Into n cap. It's ei. Ei is how much? The ei is I cap plus 2j cap minus 3k cap upon 14. Take the dot with n cap.
oh, sir, sorry, minus 3.
So this turns out to be 1, 2, 2, 2, 2, 2, cancel and minus 3 by root 14, root 6. So by the way, this will give you root 6 becomes 6. So I can divide by 2, minus 3 into I cap 2j cap minus 3k cap upon root 14. And this I can attach plus 2i minus j plus k by 2 root 14, right? Yeah. So you can find the answer. Okay. You can also prove something. If two mirrors are mutually perpendicular, that's a very famous like question. If two mirrors are mutually perpendicular, then any ray coming at any angle will always reflect eventually and will go parallel to the incident light. So the total deviation suffered is how much? Can you see? The total deviation suffered is 180 degree.
360.
Eh? 360. Light
No,
is
no, sorry.
coming this way.
Sorry. 180, 180. No.
It means every incident ray, no matter what, will eventually reverse the path. So two mirror at right angle is a very good reflector in a way. It will only reverse the light. So any image coming from here, you can see on this side. So a person, if the object is kept here, you can exactly see the object on other side using the two reflecting mirror. So that's why at various for security reasons they install the two perpendicular mirror in the corner so that they can see anything coming from other side. That's interesting. So by strategically placing the mirror can create the good security measure without deploying a person there. So of course, in the old times, like you must have watched the movie, like in which the king is looking at the queen using the mirror through multiple reflections. I watching some recent movie, I think. So okay, anyway, so we can prove it. Vector form also by common sense. So by common sense, why we can prove, because if this is theta, this is theta. This is 90 minus theta. This is, and because these two are 90 theta, this will be how much? This will be 2 theta, and this is how much? 180 minus 2 theta. And we know that for parallel lines, the sum of the interior allied angle is 180, which you can see. So since sum of interior allied angles is pi, therefore reflected beam will be NT parallel to incident. So we can prove it geometrically using the simple class 9th basic geometry. But there's a nicer way of proving it. And I can prove it for any random. Let me do it separately. Clutter it. So if we have two plane mirror, so how to prove it in general? So if I call this as some n vector, and if I call this as ei, then this will be, we can call it er. But er becomes what er becomes?
EI for the next reflection.
So we can call this as n dash, and the n dash and n are mutually perpendicular, right? So this we can say er dash. So let's try to write the formula first. So er dash you can write as ei, which is er, minus twice of er dot n dash. Yeah, that's it only. And now let's substitute the value of er. What is er by the way? EI minus 2i EI dot n cap into, oh, n cap is missing, n dash cap into n cap, right? This is EI, ER value minus ER is this much, EI minus, oh, yeah, EI dot n cap, yeah, minus whatever you can is twice of ER is again EI dot, sorry, EI minus twice EI dot n cap into n cap dot n dash into n dash. That's too much. Oh, so ER dash comes up to how much? EI minus 2 EI dot n into n minus, yeah. Now n dash EI cap. If you have, if you multiply inside, it will become n dash EI cap twice EI dot n dash, because n dot n dash is 0 because they are mutually perpendicular,
Yes.
and whole into n dash. Okay. So we have to prove that EI and ER are opposite, no?
So that term will also get cancelled, right? If you multiply n dash n cap.
If I'm applying,
So that the first term in the bracket with the n cap dash.
no, this is not multiplied. No, this is like we cannot take dot with a number. EI dot n cap is a number. Number into n cap is a vector only. That's it. You cannot write further. Just one. EI dot n dash into n cap, and then n cap dot n dash cap, which is 0 into n is nothing. Yeah, so what you can write is twice ah hmm. So basically we need to write the n and n dash relation so that we can substitute, and how we can write n and n dash relation if these two are mutually perpendicular. The only information we know is that n and n dash are mutually perpendicular. That's it. So how we can use it? Yeah, not n dash. This is vi dot n dash. Anyway, I think eventually we have to write the angle only. The only way I can prove it is using the angle. But that is like okay, if you use the angle itself, then there is no point. Okay. Anyway, coming to this, what we can do now, and that's hmm, Yeah, if we can, so that is of no use. We have to prove that EI and ER having the angle. We can take the dot of EI and ER. That is what will happen. If the dot should be taken, then answer should be -1. Even that is a way of thinking. You take the dot of EI and ER, the answer should be -1. Can you take the dot and tell me if it is giving the answer? Take the dot between EI and ER dash.
Sir, can I repeat?
Take the dot between EI cap and ER dash cap. And the answer is -1, then it's an anti-parallel, right? Okay, let me do. I mean, you can do. I'm also trying. No, I'm just trying to make it a complete vector equation without knowing the direction and all. Like no easy method, a generalized method. ER is EI minus twice of EI dot n cap into n cap, and that's ER. And ER dash is ER minus twice of ER dot n dash into n dash. So let's take the ER dash completely will be EI minus twice EI dot n cap minus twice dot n dash. So it's so basically, if you look carefully, okay, if I choose some angle, because I think this angle is required. So if I choose the angle as theta, so this will be 90 minus, right? So what is the angle between EI and N? Pi minus theta. And what is the angle between EI and so angle between EI and N dash will be how much? What is this angle? Okay, this angle. 90 minus theta. This is 90 plus. Okay, so it's 90 plus and 90 minus theta. I think we should use that relation. So ER dash is how much? EI minus twice. So EI dot n cap. EI dot n cap is, if you remember, EI dot n cap is minus cos theta, correct?
Yes.
And EI dot n dash is 90 plus theta. So cos 90 is again minus sin theta, right? Isn't it? So sin theta n dash. Cos theta n cap and sin theta. Basically, this is ER, isn't it? So if you look carefully, this is this itself is like ER cos theta n cap. ER is cos theta n cap. Right? Okay, this is one cos theta n cap and one sin theta. Ah, so this way it is not coming. I mean, this is there should be some simple way. Using ICAP and JCAP it is easy because there we don't have any problem. Why it is not coming?
So this proof is only for the perpendicular mirror, right?
Yeah, only for two mutually perpendicular mirror we can always find this relation. I mean, just you need to remember that they are always independent, not to solve question. I mean, it is always independent, always. Okay. And also you can understand something. Let's say if we have the object like this, a small tiny object which is oriented like this. Let me draw a parallel line, to understand that how the reflection will affect the answer. So the tip will come here, you can see, and this will come here. So what you can realize that the reflected light, the image will be something like this. Do you realize this? If the object, this is the object of this orientation, then this is the image. So object and image will invert. Do you realize this?
Oh, so that so can you explain this? The image will be inverted.
So you can see yourself now how the tip is moving, the orange line, how the tail is moving, the yellow line. If I join the orange with the yellow, what I'll get?
Yes, inverted.
So they are inverted, na?
Yes.
So with respect to object, I mean object, the image will be inverted by these two mutually perpendicular. Understood? So sometimes you need to just do it by your bare hand and try to get the answer. I mean, you cannot solve every question and prove it. So because it's a geometrical object, so some geometrical idea it will always have. You must draw to understand, draw to feel it. Okay. Anyway, it has taken more than it deserves the time. Okay, now the most important concept is called image formed by two plane mirror.
Sir, but for image to form, two reflected rays should intersect, right?
Pardon?
So for image to form, two reflected rays should intersect, right?
Yeah, of course. I mean, that's called the real image. What is happening here? The images are simply like translating itself, like it's like lateral inversion. So you can draw the image if you want to have two rays, so you can take another direction So from here you can choose some other action. Okay. It will go like this and it may reflect this way. It's quite possible it may reflect like this. So maybe here. Understood. Like we don't know like how it will go. So you can take two rays, not an issue. So one ray is going there, then you have to take some ray at some angle which will eventually reach there. Okay.
Okay.
So that we don't know how it will possible. It may be like this. I don't know. So of course you can take two rays. I mean, what we're doing is we're just understanding the idea that how the ray from the tip will go and how the ray from the tail will go. And the tip and the tail, because that represents the object end points, we can understand that the image will be inverted because the ray from the tail is going this way and that. But if you want to form the image, first of all, you need to form multiple images. So it's okay, we'll see now that how image is formed. So the next topic is that only. So image formed by two plane mirrors. Okay. So we'll take the case one. If mirrors are parallel to each other. So let's say you have two plane mirrors. So let's say we have an object at a distance A and B. So it's not symmetrically kept, it's just kept at some random separation. So if A and B are the distance from the mirror, as you can see, how the image formation will take place. So first of all, light ray from the object will go in all directions. So we'll first take the first incident ray for both mirrors separate. So the light ray going on the left will be right will be the first incident for the mirror on the right. Let's call it M1. And the light ray going this way will be the first incident ray for the mirror number 2. So what will happen? This will go like this. It will reflect. It will go like this. It will reflect. Now, once you reflect it, now this will become the second incident ray. And now this will become the second incident ray. So what you can realize that the reflected ray of each mirror becomes the incident ray for the next image forms. But this will never stop. Now, because I have shown at some angle, so the light ray will eventually exceed the mirror. But imagine that angle is almost zero. So how many reflections will occur?
Infinite.
Infinite. It means how many images will form?
Infinite.
Infinite. It means it will never stop. It will keep on forming the image, and every time the reflected of one will become the incident of the other. Okay. So what I'll do is I'll try to draw few of them so that you can realize what exactly happens. So first of all, this ray will hit like this, and so the first image will form here, correct? At a distance b, and the first image from the here will be at a distance a exactly behind. So can we say this as the, okay, let's name it first again. So this point is called the image number 1. Okay, image formed by the first mirror. It is clear, and this will
Yes.
be image formed by the second mirror. And these are the first images of each mirror, the first image formed by each mirror. But the thing will not stop here. The light ray traveling at some angle. Okay, let me get thinner one. Nice. So this will be actually, reflecting from here, something like this, isn't it? So that I can make it dot dashed line eventually. And similarly, you can see the light ray will move this way. So the object, okay, which is already there, will form the first image, as you can see, at A and B, and now the time is for the second reflection. Okay, just okay. So now what will happen? We are ready for the next reflection. So now this is the incident ray for the mirror 2, the blue one, and the pink one is the incident ray for the mirror 1. The next reflection will give you the next image. So I will draw later on, but I will tell you how where the image is formed. So the object, the virtually object, where is the object? So the O is the real object. You got the image A and B. Now this point I1 is acting as a virtual object for the, not virtual, in fact I would say I1 is the real object for the mirror M2. Can you see that?
Ah, yes.
Because if M2 will trace back, it will get I1, isn't it?
Yes.
Am I audible, guys?
Yes.
Am I audible?
Yes.
Hello, hello, hello.
Yes, sir.
Am I audible, guys? Hello,
Yes, sir.
hello.
Hello.
Am I audible?
Yes, sir.
Yes, I mean, I'm not able to hear you guys. Okay. So try to log in again. Maybe that will help. So you can see that I1, see this light ray, if you look carefully, this light ray is actually coming to this mirror. And it looks like it is coming from here. So image of the M1. Okay, am I audible now?
Hello.
I think your voice is still not coming.
Hello.
So the first image by the mirror M1 is actually acting as the object for the mirror M2. You can see that. And the first image of I2 is acting as the image for the object for the mirror M1. So I1 is in front of M2. So that means the light ray will come from I1. I2 is in front of M1, but it is behind M2. So I2 cannot, I mean, I2 is something which will never form image because of M2 because it's behind. But I2 is in front of M1. You can think this way, the front and the behind concept. So any image which is in front of the mirror will be acting as the object. So I1 is the object for M2 now, and I2 is the object for M1 now. Do you realize this? What I'm saying? The I1 is the object for M2, and I2 is the object for M1. So now the next step will be you can simply see this. So the distance of I1 from M2 is how much? Can you calculate? A plus B plus B, A plus 2B. So we have to move 2B behind. Basically, the distance is this much. This is the image formed by M2 for I1, which is A plus 2B behind. And similarly, the the I2 becomes the object for M1 and it form the image somewhere here. So the I1 will form the image for the M2 and I2 will form the image, I mean, eventually for M1. The distance we can easily locate. It's A plus 2B and the other is B plus 2A. So that's why only the shorter there is the bigger line. So now you can draw the next incident line like this, something like this. And you can draw it over here. Too much of geometry. So technically these things are very easy, but drawing wise it's really challenging. Sometimes it's very difficult to draw properly. So now how to name it? Like what we should name it? So this is called the image by the first mirror, but it's the second image we call I1 dash. Then this is called I2 dash. Again, it will repeat. Like this phenomena will keep on repeating, and of course we cannot keep on drawing. That's difficult part. And then you will get the infinite images. So I have just shown few diagrams. I mean, few images that you can relate to how it is formed. The rest is like infinite. Such things will happen, and you will get the answer. So how to remember these answers? Like how to get the I1 dash, I2 dash, and I2 double dash, and I2 triple dash, and so on, without actually drawing this diagram. So it's a common sense you can think about. So we have a simple method called crisscross method. So if M1 and M2 are two mirrors, the first image of M1 is at what distance? You can see B distance. And the first image of M2 is at what distance? A distance. Do you realize?
Sir. Hello.
No. So what do? You draw crisscross line. And the line will have the separation between the mirror is how much? A plus B, the separation between the mirror. So just add the A plus B value to both values. So you get A plus B plus B, which is A plus 2, and then A plus B, which is 2A plus B. So you can clearly see the next image. The next image for M1 will be 2A plus B ahead, and next image for M2 will be A plus 2B ahead. Behind, I mean behind. Then if you want to know the next image, again do the crisscross. I hope this is clear why we are doing crisscross. So I will do one more and then we can leave. Then again add A plus B. So what we get here? A plus B plus A plus 2B, which is 2A plus 3B. And then 3A plus 2B. So in this way, you can keep on getting the images, which is not very difficult. So A, 3A, and I mean there is a very nice impact formula. You can derive the recurring relation. So if you're interested, you can find the recurring relation as a homework. So as a hint, I can give you that the alternate image will have the recurring relation, not the continuous image. You can write the relation for the odd images and even images. So that is following a pattern, mathematical pattern actually. So in case of flame mirrors, flame mirror, if there is no inclination, you will always get some image in front of the first and in front of the second, and therefore they will keep on forming the images forever. And therefore the number of image form will be infinite. So it will never stop. No question of stopping. But the real fun starts when they become inclined to each other. So the moment we have two mirrors inclined to each other, and let's start to bring some objects. And how to bring the object? In between the mirror, somewhere randomly somewhere. I can keep it symmetrical, I can keep it asymmetrical, like not exactly at angle bisecting. So you can keep it anywhere, like here, like here. I'm keeping at internal point O. And here we don't take distance, we take angle alpha beta. And why we do so, it will be clear very soon. Okay. So if you think in terms of distance, so we have to look at the peripheral suppression line. And what you can realize, I hope you can realize, it will form isosceles triangle, right? Can you see that? And therefore the first image will be at the same angle away by each mirror, isn't it? Do you realize this? No. You can see this is I2, this is I1. Now I2 is the image. I1 becomes the image, object for the M2 next, object, and I2 becomes the next object for M1. So if you try to find the new distance, it is something like this. So I'm drawing the perpendicular line to this. So if you look at the triangle, the next isosceles triangle is alpha plus 2 beta. So this will be again, and if you look at this isosceles triangle, it is 2 alpha plus beta. So now we got the next images. Maybe I can say I2 dash and I1 dash. So what you can see that images will keep on turning. In this case, if you look carefully, it is going to go higher and higher and higher. It will keep on turning actually. And of course, I cannot keep on drawing like this. So what you need to realize? What you need to realize is that all images will fall on a circle. Let me draw the circle first. And now let me draw the mirror again. So the intersection of mirror is the center. And the radius is nothing but the object distance. Basically, what we call radius is the object distance from the center. So let's call it C. That's O is object. And our object is somewhere here. So no matter which object you choose between the mirror, every image will fall on this circle. So because they are tilted, they are not on the same line, rather they are on the same curve or the same circle. So if I go with the best case scenario, something like this, let me extend this circle on the back side. This is something which we need to realize. So you can see this is a portion, or this is the region in which if you have any object, it is neither in front of the first mirror nor in front of the second mirror. It is called the dead zone because nothing, no light from here can go to the or can hit the mirror surface. So you cannot draw a ray which can be incident to the any mirror. Can we draw? It's behind the mirror. It's behind the mirror. I cannot draw something here like on the front face. Do you realize this? So from here, we cannot draw any line which can hit the mirror. But if you are slightly this side, you can hit the mirror. Yeah, you can hit. And if you're slightly on this side, you can at least hit this mirror. Now, what does it mean? That the moment you make the two mirrors at incline at some angle, they cannot form infinite images because eventually some image will fall in the dead zone. And the moment it will fall there, no more ray will be able to hit the mirror. So now the concept of finiteness will come. Like eventually, we can get the finite images. Okay. And if I choose the alpha and beta as angle, the second image will be alpha away, then third will be like alpha plus 2 beta away. Eventually, all of the images, in fact, you can see the first mirror can form images till the image is falling this angle. And second will fall images till it is formed the image till this angle. So till the object is in this range of angle for the mirror M1, M2, the image will be formed. The moment the image will just fall into the dead zone, the image formation will stop. So if the angle I mean, if you keep on taking the alpha, then next will be like some more angle, then some more angle, some more angle. If you add all angle, the angle from this side and the angle from this side cannot exceed 360. The sum cannot exceed 360. Individually, it cannot exceed 180. So the image formed by each mirror cannot go away more than 180. And the sum of the two mirrors, the image formed by two mirrors, so the sum of the angle that these images will form cannot exceed 360. Okay. Now, if I take alpha beta equal, because that will be easy for you to understand. If alpha and beta will be equal, if it is perfectly symmetrically placed object, what will happen? If I put this symmetrical, then one thing is clear, that both mirror will form similar or same number of images, isn't it? And in this case, the last image will be exactly here. But because the image just before will be somewhere here. For this mirror also, and for this mirror also. And now they will form the last image, and their last image will coincide exactly at the midpoint. Okay. So here the angle will follow a very nice pattern. You can just calculate. Let's make it theta and theta. So the first image will be theta away, then next will be 3 theta away, I think, right? The next will be how much? I think it will follow a very nice pattern. Now what you can see, that in case of symmetrical object, if the object is placed symmetrically, there's something really nice happens. What happens? The last image will coincide at the opposite end, and that will be the dead zone. And because that's a dead zone, you cannot expect any further image to be formed. So if the left mirror forms 10 images and right forms 10 images, then how many images will you see? If both the mirror forms 10 and 10 images, then how many images we can see? 19, correct. Because the last image will always coincide in case of symmetricity. And if both forms 11 and 11, still we get the how much? If the left forms 11, right forms 11, then how many will get? 11, 11 both. 11 left, 11 right. The total will be how much? 21. Like again, the last will coincide. Correct. So whenever we have the symmetricity, if the number of images forms are either odd or even by each mirror. So basically, it's like a number of images like even by both mirrors. So when the number of images comes out to be even, if you add the number, it will be always even, because odd plus odd is also even plus even is also even. So whenever we have the even number of images, the last image must be coinciding, and therefore you won't get the one, I mean, exact image. You will get one less image. If you form the, let's say, if the left forms 10 images and right forms the 11 images, and the object is kept symmetrical. Think about it. Object is still symmetrical, but the left forms 10 and the right forms 11. That's not possible. Rather, what will happen? The next image will overlap. It means the 11th of the first goes to the first of the second, and vice versa. When the total number of images formed by the mirror is odd number and object is kept at symmetricity, you will still get the one less images, because the last you cannot see, like it will coincide. So, I mean, of course, it's not, you're not supposed to mug up the formula. There is a simple way to remember all this. There is a simple formula to remember. So I just wanted to give you some intuition, like how to think about it. So number of images formed by two. So step one, you calculate M, which we write as 360 by angle between the mirror. Theta is the, so if M is even, if you get M as even, then number of images will be,
So no.
you can write as M minus 1. That's simple, without any doubt. If M is odd number, if M is odd, then we have to ask something like, is object symmetrically placed or asymmetrically placed? If object is symmetrically placed, then number of images equals to again one less. If object is asymmetrical, then number of images will be m. Like if it is asymmetrical, then you can take the odd number as the answer. And if m is fraction, then fraction represents the dead zone. So you can take the integral part and you can tell the answer. That's it. Then number of images will be. So I hope you remember the greatest integer x, or you can say the ceiling of, how we write, the lower limit, the ceiling and the floor method, right? This is called, I mean, this is called floor. So you take the lower value, like a lesser value. M is a number which you get by dividing 360 by theta. M is like the total number of images that you can imagine. So let's say if the left will form something, the right will form something, then the total is how much. The rigorous proof is very difficult to give. I mean, it's like a recursive relation which I need to prove and so on. So I will share a document which you can read if you want to go even more deeper into the derivation. But I mean, of course, I mean they are also give the intuition only. I mean, they are not interested in derivation, just basic intuition. Okay, it's clear. Yeah. Why your voice is like you're not connected with your audio? What is happening? What is happening?
Sir, can you hear me?
Okay, let me reconnect. If it is on, then I can. Am I audible now?
Yes.
Yeah, I can hear you. Okay. Now again, we have a crisscross method also, which will give you the idea that what exactly happens. So
So
let's
can you just explain the dead zone part again?
which part?
Dead zone.
Once again, which one?
Dead zones.
The dead zone. Okay. See, if we have any mirror, to form the image, the object must be in front of the mirror, isn't it?
Yes.
If the object is here, it can form image. If we have the object here, is it possible for the mirror to form image?
No.
So if I extend this line, so any object on this side will not form the image, isn't it?
Yes.
Okay. Now let's say we have another mirror. So this new mirror will form the image only when the object is this side. Correct?
Yes.
If I extend the line, any object on this line, this side will not form the image. Correct? So you can see there is an intersection of these two lines, right? This region. Here, this entire point in this region is neither in front of the first nor in front of the second. It's behind both mirrors. Do you realize?
Yes, Anish.
And because it's behind both the mirror, so the moment the image will fall in that zone, no more reflection will take place. It is like the light ray will go away from the mirror. Understood?
Yes.
And therefore, uh, you won't get any form further. So that's called the dead zone. Dead zone means the region behind both mirrors, the common intersection point of the two mirrors. So I hope this is clear.
Yes, sir.
Okay, I mean this is confusing. I have taken theta. This is actually, let's get theta by 2 theta. Let's say the theta is the angle between the mirror. So you can see now here, if you look carefully, the first image is alpha, second is alpha plus 2 beta. So alpha plus 2 beta. Plus next will be what if you guess? It will be maybe like 3 alpha plus how much? 3 beta. So if you add all angle like this on the left side, it cannot exceed. It will be less than equals to 180. And similarly, you can do it for the right side. So it will be also less than equals to 180. Understood?
Yes.
So the sum will be equals to how much? Like up to 360. No?
Yes. 360.
On both sides, then it cannot exceed 360. So because alpha plus beta is called theta, so I can take the pair of alpha plus beta on both sides, and then I can add, and then I can prove. Okay, it's a rigorous, I mean, process. I mean, if you want, you can do it. I mean, you really need some patience. You need to devote a lot of time to understand. Okay, so you can do it. It's not impossible. I mean, just I haven't never done this before. So I'm just ignoring it. Okay, so there is again crisscross method for the same. So I'll take some cases, and that will be easy for you. So let's say we have two mirrors and inclined to 60 degree, and my object is not symmetrically placed. It's placed in a way that the one side is 20 degree, another is, let's say, 40 degree. Okay, let's mirror one mirror. So you draw the crisscross method M1. So M1 will form the first image at 20 degree for sure, and the M2 will form 40 degree for sure. That's for sure. The angle between them is 60 degrees. So add values. 20 plus 40 plus 60 is 100, and this is 80. Now, because the values individually are less than 180, so we can accept the value, and the sum is also less than 360, so we can again. So how we add? We add all three values, this angle and this. 100 plus 60 is how much? 160. 160 plus 80, how much? 240, which is less than 360, so we can proceed further. So go one step ahead. Add again 60. This is how much? 160. So this is acceptable because 160 is less than 180. And this is how much? 80 plus 60 is how much?
140.
This is also acceptable because it is less than 180. But if you add all three, what is happening? Oh, this is perfect 360, right? This is exactly 360, isn't it?
No.
Now, if it is exactly 360, it means the last image must be coinciding. So if the sum is perfect, if the last image sum is perfect, I cannot proceed further because now the angle will exceed 180 in each case, and also the sum will be more than 360. So we cannot proceed further. So what we can say, since 140 plus 60 plus 160 is 360. So when you capture the angle completely, it means the last image will be overlapping. So
So where are
last,
you adding 60 also?
this is 60, 140 plus 60, this angle. We add like this always. We check individually and we check the sum of, because see, this angle you are measuring from this and this, and then the total angle is this plus this plus this, no? Left, center, right.
No.
Understood?
Yes.
The angle between mirror will also matter. So if the sum is perfectly 360, it means the last image will coincide. So the number of images, that's called n equals to, count 1, 2, 3, 4, 5, 6. 6 minus 1, how much?
Fine.
Now let's do by formula. M equals to 360 by theta, which is 60. Answer is 6. 6 is even number. N equals to, understood. But the crisscross is nice because it will give you the exact angle of each image. Okay.
Yes.
So you can do for yourself. Let's say if I take a value like,
So, sir, I have just one step. In the last page, we are measuring the 100 degrees from the object or from the mirror angle.
for mirror, every angle is from mirror, not from object. The 20 degree is from the mirror, na? Because from object is 40 degree. If I go this way, if you go this way, 20, how much is angle? 40 degrees, na? But we are taking angle from here, na? This 20. We're not taking the angle from the object line. We are taking from the,
Okay. Mirror line.
so okay, all right. So if I take maybe, if we have two mirrors which are inclined to each other at right angle, then it is pretty much easy for you. You can exactly draw the images. That's so easy. Now, if I choose any object, let's say I have already drawn this circle because I need it. If this is the actual object, then every image this object will form will be in this circle, exactly like this, and it will be symmetrical also. You can see clearly. So the first image will be here, that this mirror will form M1. The second will be here, that M2 will form. Now you can see I1 is in front of M2, so I1 will form the image here. I1 dash. That's funny. This is I2 dash because it's in front of M2, and I2 is in front of M1, so it will form the I1 dash. And what you can see that these two images will coincide here. So actually, the point on the corner having two images. Do you realize this?
Yes.
And of course, this is not accurately drawn diagram. You can understand. So when the angle between the mirror is 90 degree, you will always have the how many images you can see distinctly,
3 images.
and that formula will also give you the answer. M equals to 360 by 90. It is 4. N equals to. So let's take some odd value or odd number question. Maybe what? How much? 18 degree. Yeah. How much? No, no, 18. Some odd number. I think odd number will get yes or no.
So it's M minus 3. No?
Or we can take 120 degree. You can take 120 degree. If we have two mirror at 120 degree, so it's a really bad scenario because in this case, we will have a very big dead zone, right?
Yes.
So this entire region is a dead zone. So if we choose, let me draw a circle first. I need a circle eventually. Take any object. You can see this angle is even bigger than this. So the first image itself will be somewhere here, right? If this is the object, if this is the mirror M1, I can say this is the I1. And similarly for the second side, the angle this much, you can see even this is bigger than this one. So you can see that every angle so this angle is 60 degrees, so we have a quite a big dead zone. This is also 60 degrees. So if one will be more than, because if it is more than 60, it will be on this side. This is how much? Less than 60. So it will be on this side. So this will be some. Because if I take one angle is more than 60, the other will be less than 60. So the answer will be somewhere here. But the next image, I see I1 cannot form the image. First of all, I1 is in red zone, so that's gone. And the very next image, even I2 will try to form, it will fall in the dead zone, right? So how many images you can see?
0.
Eh? Why zero? I1, I2 is two images. Eh?
But they are falling in the dead zone.
So I2 is in front of M1, but the very next image will be from this where? Somewhere here, right?
So then one image.
This is I2 dash. There are three images, no? See, once you fall in the dead zone, now further the image will not form, but that is the image form, no? I1 is the image form. I2 is the image form. I2 dash is the image form. Okay, you can take some angle. Let's say, imagine this is 70 degrees. So this will be how much? 50 degree. This is 50 degree. So this is how much? 10 degree. So this is 10 degree extra. So the O will form the first image on the at I1. Do you realize this? O
Yes.
will form the first image at I1. Now I1 will not form further. That's and O will form the first image at I2 due to M2. But M2 can form one more images on the other side, which is I2 dash. Okay.
Mouse wonderful.
Now, what if it is exactly symmetrical? If the O is at symmetricity, then both image will form on the boundary of the dead zone, right?
Yes.
And therefore, you cannot see further images because if it is at boundary also, no more image because it will become parallel to the line. So, how many images will be there?
2.
Just two. So now comes the formula. If you try to use the formula in 360 by 120, how much is the answer? 3. So 3 is the odd number. So if you look at the relation, if object is symmetrically placed in odd case also, even in odd case, the image will be one less. See? For symmetricity, it is one less. So for asymmetricity, it is same, 3 images. So if symmetrical,
2.
yeah, if symmetrically placed, 2. If asymmetrically placed, then you'll get 3 images. Do you understand this?
Yes.
You can realize from here. And let's do it from the crisscross method, like how crisscross will help you in getting the answer. So we have M1, we have M2. Okay. So the angle between the mirror is 120. Well, let's say one is 50 degree, other is 70. Now, angle between is 120. If I add 120 to 70, what will happen? It is 190. Correct? What does it mean? If it is 190, then it exceeds the
1. Oh.
it exceeds
Dead
the
zone. Dead zone.
yeah. So this is this is like exceeding values we cannot count it. Add this one,
170.
we can count it. So how many images? One,
3.
3. Okay. Now, if symmetrical, if I take 60 and 60, 180, 180. Okay. Now you can see that if you have 180, the problem is if you sum these three, it exceeds 360. Okay. The sum of these two itself is 360. 180 is anyway bigger one. So you cannot take like both of them. So it should be, the angle should be less than 180. If even it is 180, we can ignore. Ignore, ignore. What will have left? What will left with? Just two answers. Because every individual angle should be less than 180, and the sum should be less than equals to 360. If sum is 360, it means the last image is one side. It's clear.
Yes, sir.
So you can use the crisscross method, or you can use the other method to solve any question of plane mirror. In case of plane mirror, the rule is simple. If it is, and there is something interesting, like if I choose some random angle, some any fractional value, let's say take that angle also. So if theta I take as maybe 50 degree. So what's the answer? 360 by 50. So this will be how much? 10.2. So we can ignore the fraction. So number of things will be 7.
So then,
Okay. Even if I take theta equals to 55 degree, let's see how much it is.
well, 5 images.
360 by. So it's 6.5. So we will take the. So what I'm trying to understand that, okay, just a moment. Yeah, if you take any angle, let's say you take angle the fraction will be how much? So even the fraction, let's say even if it goes to 8, let's say, in fact I can make it. Ah, let's take angle from 46. From 46 to 40, 55, 55, not 50. Take any angle from 46 to 50. What do you expect? The answer? So in fact, you can take 45 also. I mean, this is very interesting. Remove this. So if theta is 45, what's the answer?
8. M is equal to 8.
By 45, which is 8. 8 is even, n will be 7. So even at
Yes.
45 degree, number of images 7, and even at 50 degree, number of images 7. So we cannot say what we cannot say. We cannot say if the number of images given to you, we cannot judge the angle. Given the angle, we can find the number of images, but given the image, can you find the angle given between the images?
No. We
No.
can find the range.
Yeah, we can find the range actually. That's exactly the question. So if I give you, if
So in that 55 degree, the what was the rule? Sir? Number of images will be 6 million or 5.
it's 6.54, so number of images will be 6, the integer part. In that case, we don't take the even and odd because it's a fraction. So we are removing the fraction to get the answer. That's it. So no need to
Okay.
think of even and odd. Okay. So if angle is given, we can find the exact number of images. If image is given, we cannot find the single angle. Rather, we can find the range of angle. So that's very important point to remember. So we can put as a note, if angle is given between the mirror, then we can find the exact number of images, but vice versa is not possible. Rather, given the number of images, we can find the range of angle possible between the images. Chalo. So let let's make it a question. If the number of images is 6, then find the range of angle. Okay, go ahead. Got the question?
Yes.
Okay, go ahead and solve this.
So 50 to 60 degrees.
Okay, maybe that should be correct. Okay. So 6 means the answer could be 7 and symmetrical.
Yes.
If the n is 6, then what are the possible values? So m can be 7 and object is symmetrical, or m can be 6 point something, because anyway the answer will be 6 only. So m can be anything beyond 6, like more than 6. So it can go up to 7 also, isn't it?
Yes.
Is this clear?
Yeah.
So m must be more than 6 for sure. I mean, it cannot be exactly 6. If m is exactly 6, then it is the even number, so answer will be 5. So exact is not possible. So it will be some fraction. So it is 6 point something. So 360 by 60 is the 6 value, correct? And 360 by 7 is how much?
51.4.
51 point.
4.
Okay. So because 6 is exactly not possible, so the angle will be more than 60. Sorry, less than 60.
More than equal to 15.5.
Yeah, but more than equals to this. So normally what will happen, they will give you the number of image and they will give you option A, like say 58 degree, B 60 degrees, C 52 degree, D 50 degrees. So which of the following is correct option? So it becomes a multiple choice question.
58 and 52.
Yeah, so these are the right answers. Okay. So having known these values, now I think we're done with all of the plane mirror concept. Anything left from the plane mirror? No, no. So there's one more concept called the thick mirror. Okay, let me teach you that. These are very basic questions you might have studied in maybe thick mirror. So in case of thickness, a mirror is only the reflecting surface. But when we actually go and buy the looking glass, what we call is looking glass. So looking glass is made from the I think sodium borosilicate, something like that. And the glass is not the mirror. What we need to understand that the painting behind the glass is the mirror. Glass is called the protective layer actually. So the mirror part is the silvering part, which you silver the behind of the mirror, which allows the light to go back. And the glass is transparent, so you can see the mirror. So in a way, you see the mirror through the glass. Glass is not the mirror. Okay. So, but we cannot put the thin layer in air. So glass is a nice binder actually. So when we put over the glass, there are two things which happens really good. One is it stays there for a long time because it binds with the glass easily, and it is protected by the glass itself. Okay. So every mirror, the painting is called the behind what you paint. There's a very thin painting actually which you don't see. So that is the mirror. In organic chemistry, also we'll study the aldol condensation, the silver mirror test of aldehydes. It's very interesting experiment. So the silvering of mirror over thick glass. Let's say take some thick glass. I'm just exaggerating the glass thickness. So a light coming will first hit the surface, top surface of glass. See, this is the mirror. So when I say mirror, here is the mirror. The glass is not the mirror. This is the mirror. So first of all, this light will bend towards the normal. So it will suffer the deviation because of the Snell's law. So now this is the mirror part. Okay. So now it will hit the mirror, and after hitting, it will reflect back. Again, let me draw the normal here. So then it will refract. But what is it will some part will also reflect back. There is nothing like 100% reflection or 100% reflection. A partial reflection will take place, but that is very small, and then again reflection will take place. Again, this story will not stop here. This will repeat infinite.
So this takes place only for thick mirror.
Anything more than measurable value, it will take place. Thick means this is the thick mirror. If you want to know exactly plane mirror, then you know how to make the exact plane mirror by glazing the metallic surface. So metals are perfect mirror. They don't have thickness. Understand? So that's why in the old days the queen used to have the mirror made of silver. So if you polish the silver very nicely, it will start becoming or acting as a mirror. So they used to see themselves in silver itself, the metal. They never use the glass. Still in India, it is produced. It's very expensive. It's just made for the foreigners. If you go to Jaipur, it is still in tradition. The cost of the mirror is 5 lakhs. If you want, you want. You're happy with the normal mirror.
With the normal.
Be happy. I don't see mirror also. Anyway, the whole idea is at every interface we have two phenomena which take place which you don't realize. One is called the reflection, another is called the reflection. So here the light ray will reflect also and refract also. What I'll do is I'll slightly better. Looks nice. And then at every interface the same thing will happen. You will have reflection and refraction. And again same. This is sufficient. I need to do any more. So look at this. For transparent surface, the property of transparent surface is to refract more or reflect more. What do they do more? What is the dominating feature?
Therefore, transparent, refract.
Yeah, they will refract more. So if this is the, let's say, 100 joule of energy or something like 100%, the light entering will be almost 90%. But the light reflecting back is only 10%. Okay, you can think this like 10%, 10% reflection and majority is refraction. But 90 will hit the mirror, will go back 90, right? 90 hit, 90 back. Coming to this point, how much will refract? 90% of the total, which is how much? 81%. And how much will reflect back? Only 9%. Do you realize this? The percentage decomposition?
So can I repeat again? 81%.
Right? 90% of 90 is how much? What is the 90% of 90? 90% of 90 is how much?
81.
Oh, you don't know math, basic math. 90% 90 is how much? Come on.
81.
81. That is what I have written. So out, see what I'm taking the ratio is I'm taking 90 refraction and 10 reflection. Okay. So 100 will go, 90 will go inside and 10 will come outside. So what will happen next? 90 will hit the mirror and 90 will come back. But again, at the refraction point, only 10% will reflect and 90 will refract. So 81% will go away outside and 9 will come inside. Then this 9 will suffer further. 9 will come. You can see. So 9 will come here, 9 will go here. But out of 9%, how much will go that side? 8.1. Isn't it? And what is left? 0.9. Do you realize this?
Yes.
And then 0.9 will go, 0.9 will come. Then again 90 of 0.9, which is point
0.
how much? 0.81. And what will reflect here? 0.09. Anyway, I will not go further. Now, these are called images. So first image, second image, third image, and fourth image, and so on. So, which image is the brightest image?
Image 2.
That is the only question they ask you. Second image is brightest. but you don't see individual image. As a human eye, we see the superposition of all images. Understood? So when you look yourself in a big glass mirror, you get a lot of energy back to your eye, and therefore you see a really brighter images. So when you go to malls, they have the life-size mirrors, and you appreciate yourself by looking in the glass because it's so big that it gives you the brighter picture. You may not be that bright in reality, but of course, because of so much light hitting the mirror, your image formed is brighter than the regular. So that's why they use a lot of lightning, so that when you go to buy some maybe garment shop, you go there, they have big mirrors installed with proper lighting. When you see yourself, you see, okay, it's really looking nice and brighter. The clothes looks brighter than actual. Too much light, so they play with the light. The whole idea is the size matters in terms of enhancing the intensity of image formation, which we call brightness. So image will be brighter, and image, the brightness of the image is a function of the size of the mirror. And the way we put it is called the aperture. So aperture is the linear dimension of the mirror, and intensity depends on the area of the mirror. So intensity of image, intensity of image is, okay, not there only, is proportional to area of mirror. So bigger the mirror area, more the brightness. So intensity is the mathematical term, and we understand the physiological term is called brightness. I think I have explained something like this. In sound, like intensity and loudness. In light, it is called brightness.
Yes.
So intensity in the context of light becomes brightness. Intensity in the context of sound becomes loudness. That's a similar physiological phenomenon. So when you use the remote control to enhance the brightness in your television, what you do is mathematically you increase the energy consumption of the television, because you increase the brightness, so every pixel will consume more energy to be brighter than before, because they have to radiate more energy to make it brighter. That's simple idea. Anyway, so brightness is the physiological concept of mathematical value called intensity, and we have something called aperture. So aperture is for the greatest linear dimension of mirror. Basically, it's called the effective size of light reflecting area. So when you go to buy a mobile phone, it comes with some dimension, right? Like 6 inch, 7 inch, 8 inch, 9 inch. Like tablets are 10 inches. So what do you mean by the dimension of the tablet or the mobile phone? How they measure the length? They measure the greatest dimension, which is the diagonal actually. So this is the size of the tablet or mobile phone. So the aperture is called the greatest dimension, the greatest linear dimension that the object will have. So in case of rectangular phones or the tablets or the iPad, the diagonal is called the size. So when you go to buy a 6 inch mobile phone, you don't see at 6 inch because you don't understand the 6 inch meaning. It is only maybe 5.5 inch, maybe 5 inch, because what the measure is the diagonal. Understood?
Yes.
So the size is called the greatest linear dimension. So in case of optics, every lens or mirror or even the plane mirror will have the light reflecting area. So the biggest linear dimension of the reflecting or refracting area of mirror or lens we call aperture. Okay, so aperture is like how big the linear dimension is, and that is why intensity is always proportional to square of aperture, because aperture is the linear dimension, intensity depends on the area. This relation is useful. So as you, let's say if you have the light, I mean if you have a lens, maybe a concave lens or convex lens, these are circular piece of object. So they, you may define the radius. So if you take a radius r of a lens and if you throw the light through it, okay, I'm not talking about the radius of curvature, I'm talking about the radius of the physical dimension of the lens, not the curvature and all. So the light which can go through it is through the area pi r square. You can think that way. So light entering area or light reflecting area, so it's like effective area on which light is entering or hitting the surface. If that area will change, the image intensity will change. So that is why, like to see the, you know, the stars, we have the telescopes, and the problem is when we design the telescope, we try to see as brighter picture as possible. The reason is the stars are so far away that the light coming from the star is really sorry, really small in value. So we need a very big aperture size so that we have sufficient light to reconstruct the image. So nowadays we have the digital method. So what we do is we receive the image and we digitally enhance the image to make it really beautiful. So now we have the a variety of techniques available to achieve the same. And the old telescopes used to be very bulky in size. So if you go to the observatory across India, we have many observatories across world also. Now these observatories are old, and because they employ the biggest lens in the world, and these lenses are so heavy that even turning is a big difficult. I mean, it's, first of all, it's not portable. So they put in one observatory. It's very difficult to maintain from the scratches and all. And the biggest problem that is with the lens is that as the size of the lens increases, it starts showing something called the chromatic aberration. But for in case of star, these aberrations are of no use. In fact, it makes the star even look more beautiful. But for scientific research, for astronomical research, we are trying to design a better lens day by day, which can reduce the chromatic aberration, and then we have something like many aberration in case of lenses. So we'll come to the concept of chromatic aberration in the chapter of lens. But right now, you need to understand the concept of aperture. Aperture is the biggest, greatest linear dimension of mirror. Also, it could be for lens also, or anything. I mean, it's just a concept. Like through what area the light is entering the instrument. That's called the aperture size. And aperture will dictate the intensity part, but image formation has nothing to do with the size of the mirror or lenses. It means no matter how small you take the size of the mirror or the image or the lens, you will get the complete image, although you won't be able to see it, but image will be formed. Okay, because infinite beam can pass through one point. You can have a beam passing through this point. So even the smallest mirror can form the entire image. That's not an issue. So what you need to realize that a mirror is not forming the image. Every piece of mirror is forming the image, and every piece will form one image which will superimpose to each other, and hence you get the layer of intense. I mean brightness. So you get the layer of energy one over the other, and because of so many superposition, you get a really bright image. When you go, if you go to a swimming pool and if you try to see yourself, you can see your image, but that's very dull. The reason is the amount of reflection is very bad, very small, very less. So the intensity part depends on the reflected or refracted light. Reflected we take in case of mirror, and refracted we take in case of lenses. And this concept is useful. Like you need to know theoretically what is the meaning of aperture. Okay. And aperture will decide the what
Right.
intensity.
Yes. Intensity.
So imagine if I reduce the radius of a lens by one half, how much intensity will be affected?
So if what?
If I reduce the radius of the cross-sectional radius of the lens from R to R by 2, what will be the new intensity compared to the initial?
1/4.
One fourth. That's it. Because it depends on area. So one half of the area radius is one fourth of the area. So the intensity becomes. So let's say from a lens of radius R, from the center I remove the lens R by 2. So what will be the new intensity? Can you guess? Or we don't remove. What we do is we paint it black. So you take a radius lens of radius R, you half of the radius R by 2 up to R by 2. So from center to R by 2, I just painted black. What will be the new intensity of image on the other side?
Intensity by 4.
Hmm?
Intensity by 4.
No, no, I'm blacking out the central part of R by 2. So what is the new intensity?
So can we draw diagram of
See, imagine this is your lens and the light is going through it. Now what I do is I paint black. I like now this lens is gone. I mean light cannot go through it, right?
yes.
So what will be the new intensity of the image?
So 3/4 the
Correct.
original intensity.
So the I mu will be 3/4 of the I one. But because what we look is the area change of it. So we have 3/4 area left still, right? So the area will reduce by only 1/4. In the previous question, what I asked that if the entire radius is reduced to half, it means the light reflecting area itself is R by 2. Then the answer is 1/4. Understood?
Yes. Yes.
Okay. Now we'll come to something called reflection. Uh, reflection property of mirrors with various geometry. So okay. So you can have the mirror like elliptical mirror, you can have spherical mirror, you can have parabolic mirrors. So we'll just define in two dimensions. Of course, mirrors are three dimensions, but mathematical discussion will be taking place in two dimensions. So a sphere becomes circle, ellipsoid becomes ellipse, paraboloid becomes parabola, and sinusoid becomes sine. So I can choose any shape of mirror, but especially in the conic section, we need to know some property of conics. And what we need to know? In case of ellipsoid or elliptical mirror, ellipsoid is like actual 3 dimension and elliptical is like 2 dimensional equivalent. So in case of ellipsoid or elliptical mirror, so let's say if I paint the outer surface, the foci are called conjugate points, right? S1, S2 are called conjugate points. So in optics, we have something called conjugate points, and the conjugate point means if you keep the object at one place, the image will form at the other place. It means object and image places are interchangeable, so that's why they are called conjugate points. So any object, if you keep at here, the light after reflection, no matter how you keep, every light will pass through. Now this is the like even the way ellipse is constructed, that is obvious because it is a minimum distance phenomena, right? So it's the sum of distance S2 P to S2, S1 to P dash and P dash to S2, both are same distance, right?
Yes.
So the sum of the distances, we know it's constant, right? And in fact, it is equal to twice of the semi major axis. That is the property of ellipse. In fact, that is the shortest distance from the S1 via periphery to S2. So if you want to go from S1 to S2, touching the surface, no matter which surface you touch, all will give you the same time, same distance. So light takes same time to travel. So what I'm trying to explain that in case of elliptical mirror, the object keep at S1, it will form the image at S2 and vice versa. Because S1 S2 are conjugate points, it means the light ray will retrace the path if you just switch the location. So if O is kept at S2, the image will again at S1 and the light ray will just retrace the path. It will just reverse the arrow. So that is what you need to remember, the property of elliptical mirror. And if you draw the tangent at a mirror, like this is something which we need to know for mathematics only, not physics. So if you draw any tangent at the mirror, then this angle will be same as this angle because of the reflection property. These angles are always equal. Understood? It is clear?
So
Hmm?
yes.
Okay. So that's the law of reflection only. So the angle made by the incident ray and the reflected ray will be equal with the tangent. I'm not taking normal because normal is not visible here. Tangent we can see clearly, so we can say the angle will be, because if you make same angle with the normal, it means you make the same angle with the tangent also, right? If this is theta, this is theta. This is also no 90 theta, correct? So knowing the angle from the normal is same as knowing the angle from the tangent. It forms the same angle, and then various properties of ellipse you can invoke if you want. Now, what about the parabola? What about the parabola? In case of parabola, So if I take the mirror like this, so okay, again coming back to this ellipse, I just wanted to give one example. The lattice rectum, the semi-lattice rectum is passing to the focus and normal to the
Yes.
axis. So if light ray will hit this point, it will exactly go this way. And I hope this I mean, this length.
Yes, sir.
It's called SLR, and this is basically called 2A. This is AE and this is AE, the eccentricity. If I call this angle as theta, for what theta it will go like this. So you can find tan theta equals to SLR upon 2AE, correct? And what is SLR? The length of the semi-lattice rectum. I might have taught you in no, no. So basically, the semi-lattice rectum is harmonic mean of the minimum and the maximum separation from the foci. It looks easy, I think. A minus AE plus A plus AE, which is 2A upon A 1 minus E square. It's easy. Did I miss something? Wrote one extra A. 2 upon. So the SLR is how much? A 1 minus E square, right? Yeah, you can get the 10 theta also. That's very nice answer. 1 minus E square by 2. That's nice. Okay, so they may give you that. Okay, they can ask any question. Just I wanted to give this question. I can do by this simple form. I'll teach you the ellipse in chapter of gravitation after electrostatics, where I will teach you a different way of thinking about the ellipse. From the just two variables are sufficient to describe the entire ellipse. And what are those two variables? Okay, anyway. Now, in case of parabola, let's say this is a parabola. The standard equation y square equals to 4x. The in case of parabola, the one of the focus is near the vertex, which we call S, and the coordinate is how much? A comma 0. And in case of parabola, the other focus is at infinity. I mean, you don't get it; it's at infinity. And the property of the light ray is that if it will start from the S1, it will always try to go to the conjugate point, which is the S2. Okay. So in case of parabola, we don't represent the S2 because it is at infinity. But the idea remains same. Any light ray coming from the, I mean, any light ray coming from the foci, or sorry, not foci, focus. We have only one focus. So light ray coming from the focus will, after reflection, will go to the next focus, which is at infinity. And infinity means it will become parallel to the x-axis. I mean, the axis of the parabola. Similarly, light ray which will leave the S will go like this. So that is why the parabolic reflectors are used as a headlight, because we cannot use the spherical mirror for the headlight. The spherical mirror cannot create the parallel beam. So again, you're thinking that spherical mirrors form the parallel beam. No, they cannot form the parallel beam. So any light ray leaving the S will become parallel, and that's how we get the parallel beam of light. If you reverse the direction, any parallel beam will come and will hit the focus after reflection. Understood? Is this clear?
Yes.
So I'm particularly interested in one of the parallel beam, which is exactly above the. So this will be exactly coming horizontal will become vertical after hitting this point, which is exactly above the S. So finding the coordinate of the point P is easy. We can find easily, right? So what will be the coordinate of point P? Tell me. The coordinate of
A,
point P is
a
A comma
comma
2A. You can put x equals to A, it becomes 4A square, which is 2A. So the answer will
2,
be,
A comma 2.
and if you would go below A comma minus 2. So these are the points in a plane at which any parallel light or any horizontal light will hit and will become vertical, or you can say any light coming parallel to the x-axis will become parallel to the y-axis after hitting. Now this question we can solve in other way also, using basic slope concept. So if I draw a slope at this particular location, because this is 90 degrees, so this we can call theta. Sorry, what is theta? Can you guess what is theta? Because this is 90 degrees, so this will be 45. This is 45. This is also 45.
45.
So we can say that tan theta is tan 45 is 1 is dy by dx by definition of slope. Correct? And if you differentiate, what will get 2y dy by dx equals to 4a. And because dy by dx is 1, so this implies 2y into 1 equals to 4a. Y turns out to be 2a. Ah, we got the answer. That's the answer 2a. So the answer is a comma 2. It's clear.
Yes.
So now you can substitute the value of y and get the answer. So this is how we solve the question. If we don't know the property of parabola, but if you know the property of parabola, then it's really easy. Now coming to the circle, because circle is also very famous. Spherical mirrors are like in two dimension we can think circle. Any spherical mirror, if you think in terms of conjugate point, so is circle is a special case of ellipse in which the two foci coincide at center. So center becomes the focus. So this is center and the focus 1 and focus 2 all are the same. In case of ellipse, we have three separate points. So center is separate, center, F1, F, and circle is what? When it coincides, all three coincides. I hope this is clear.
Yes.
So if we have the spherical mirror, if it is spherical or in two dimension, think as circle, then any light ray leaving the first focus will try to come back where?
On the center middle.
And that is logical also. Any light ray hitting will come back here, because if it is a mirror, then the radius is always perpendicular to the tangent. We know this fact, right?
Yes.
So that's why in case of mirror, any ray leaving the center will come back to center, no matter what. Is this clear?
Yes.
And that's why if you have the object kept at the radius of curvature, what we do? We say that image will be formed also at radius of curvature. This is what we say, isn't it? If you remember, class 10 geometrical optics, if the object is at C, in case of mirror, the image will be also at C, real, inverted, and so on. Do you remember? No, probably don't remember this. Or you guys remember this?
Yes, sir.
So, if we create some hypothetical mirror, I mean, need not to be just conical mirrors. We can have mirrors of any shape. You should know how to approach the question. So, if I draw a sinusoidal mirror, a mirror in the shape of sine curve, like you could take a sheet of paper and you have ruffled like this. They have rolled like this, a bundle of paper. So, if the mirror is like this, let me remove the remaining part. I mean, I don't want so much. So we have a mirror from 0 to length. So x-axis. The length, this is L comma 0, this is L by 2 comma. Okay, so this is, and therefore, let's go y I give as L by 5 sine. If I put x equals to L, it becomes 5. Put the question. Okay. All right, fine. We can keep like this. 2 pi x by L. Or you can, or this is okay. Pi x by L. Leave it. So when x is L by 2, then this will come up. I have to just change the value slightly to make it meaningful. This is L. Yeah, now this will be better. This is L comma. This is L comma 0 and this is 2L comma 0. No, that's fine. Right? So if you put x equals to 2L, you get the 2 pi. That's meaningful. Complete one circle. So now the question is, if a light ray is coming this way, I mean, I want to know the point at which after hitting it becomes vertical. Now, of course, here the conjugate point we cannot find the way we did for the conic section, because in conic section we have the concept of conjugate point. In sinusoidal graph we don't have such thing. So if you may hit here, symmetrically you will go up, or you may hit here also. So there are many points possible, right? We have 4 such points at which we can expect a horizontal line will become vertical. So I just want to know all these 4 points from 0 to 12. So you can find only one point, the leftmost, and that's sufficient. The rest you can guess at it because of symmetricity. Okay, so
The pi L by 6, comma,
pi L by 6. So here again the d over d will be how much? 1 because of the obvious
yes,
reason. If it is 90 degree, then if you do a tangent, it will be always 45 degree.
45.
And therefore, what you can write is if you differentiate, you get 2 L by pi into pi by L, which is 2, right? 2. 2 is left, na? 2 cos.
2 cos pi x by L is equal to 1. So pi x by L is equal to pi by 6.
Yeah. So this becomes pi x by L is pi by 6. X is L by 6, correct?
Sorry, L by 6.
So the first answer will be L by 6, comma. If you put L by 6, what will get the answer? Pi by 6. Half L by pi. The rest you can guess symmetricity. You can subtract L by 6 from the right side and you get the answer. You can add L to L by 6, you'll get the next answer. You can add subtract L by 6 from 12, you'll get the next answer. So from the this point, you can find L by 6 ahead. From here, L by 6 behind, L by 6 ahead, L by 6 behind. And then you can get all the 4 points. And the first 2 points will have the L, what is it? L by pi above, and the next will have L by pi below. So the 4 points are L by 6, L by pi. I think that's correct.
Yes,
Yeah. And then next will be L minus L by 6, 5 L by 6, L by pi. And then next will be L plus L by 6, which is 7 L by 6 minus L
comma
by pi.
L by 6.
Minus is negative. And then 12 minus L by 6, which is 11 L by 6 minus L by pi. So we have these 4 points as answer. So you have to just know the basic of differentiation, and you can create any problem like this. It should not bother you. So with this question, I will complete the plane mirror part, and next lecture I am going to start the spherical mirror. Actually, plane mirror is difficult part. Rest are very obvious. Rest is something which you have studied already. So we never study so much of plane mirror in class 10th, right? Is in class 10th, in name of plane mirror, what we have is just it forms virtual image. That's it.
Yes. So ninth.
Pardon?
So it was in ninth.
Maybe ninth, I don't know. I mean, I studied in 8th and 10th both. In 10th, we had a chapter called optics in my time. And it was quite a good chapter. I mean, we had spherical aberration, chromatic aberration. I mean, so much thing. It was like almost 12th portion. So whatever I studied in class 10th, that was sufficient for geometry optics. Okay. Anything. So we'll see the rest in the next lecture. Bye and take care.